This video is going to walk you through an example of using the sorted edges algorithm when we have our data given in a table. So the first thing I like to do when we're doing sorted edges is to first just start with a blank set of vertices. So I'm going to label S for Seattle, H for Honolulu, L for London, M for Moscow, and C for Cairo. All right, and then we'll go ahead and add in the edges as we need them. So for sorted edges, we first start by choosing the lowest edge or the lowest weight from the table. So if we're looking at all the flight costs up here, we see that 159 is the lowest, and that's between Honolulu and Seattle. So we'll go ahead and add in that edge over here. And I also sometimes like to make kind of a table off to the side that's just telling me the cost of each edge that I add. So I'm also going to cross this number out of the table just so that we know that we've already used it. All right, so now we just repeat that process, making sure we're following the rules of the algorithm, which means no vertices with degree 3 and no closing a circuit that doesn't contain all the vertices, all 5 vertices in this case. So we move to the next lowest edge, which the next lowest weight you can see here is 245. That's between Moscow and London. And again, if I add that in, that does not cause any problems whatsoever. So I'll add 245 over there for the cost. And again, I'm just going to cross that out. That's just kind of, personally, it makes it easier for me to look at the table when I cross out the ones that I've already used. All right, moving on, the next lowest weight edge is 323. That's between London and Cairo, so that's this edge right here. And again, that doesn't cause any vertex to have degree 3. It doesn't cause a closed circuit, so we're fine to add that one. All right, the next lowest weight edge is 329, and that's between Cairo and Moscow. So that would be this edge right here. And notice that when we do that, it makes the closed circuit with just Cairo, London, and Moscow. So we definitely don't want to do that one. And since that edge isn't good, I'm just going to, again, cross it out of my table because we don't want to bother with that one at all. So then we move to the next lowest weight edge, which would be Seattle to London at 370. And if we add that edge in there, notice that London now has a degree 3 on its vertex, which we don't want either. So we're not going to use that edge at 370. Our next lowest weight from the table is Moscow to Seattle at $654. Moscow to Seattle. So if we draw in that edge there, notice that that doesn't create any problems because all of our vertices now either just have degree 1 or degree 2. So no degree 3 vertices, and we haven't closed any circuits. Okay, so in other words, 654 is kind of a good edge to use. That's the one that we want to use next. Now at this point, we could keep going in the same kind of keep following the algorithm, or we could be kind of a little clever by looking at the graph and notice here that Cairo and Honolulu are basically the 2 edges that we need to connect to complete our circuit. So if we just go ahead and draw that edge in there, Cairo to Honolulu, that's this one right here, the 801, and that's kind of the choice that we're forced into because it's the only one that will complete our circuit. If you would continue doing the sorted edges algorithm, you would eventually get there anyway. All right, so it says to write the circuit beginning in Seattle. So there's a couple different ways that you could do that. I'm just going to use the abbreviations here. You could go from kind of this way, Seattle to Honolulu to Cairo, to London, Honolulu, Cairo, to London, to Moscow, and back to Seattle. So again, that's going kind of this way around the circuit. Or you could do exactly the opposite. So maybe you wanted to start in Seattle and go this way to Moscow first. That's totally fine. It would be the exact same circuit, just written in the exact opposite order. But either way you do it, it's going to have the same cost. And to find the cost, we're going to add up the numbers that we have written over here. And I'll let you check. That ends up being $2,182. And that is a dollar amount since our flights are calculated in dollars.